72 hours ago, the world was promised a revelation. The European Space Agency unveiled what they called the closest view yet of 3I Atlas, the interstellar object that's been haunting headlines and dividing scientists for months. Billions of dollars in cutting-edge technology. 7 Mars orbiters aimed for the shot of a lifetime. And what did humanity receive? A single, fuzzy white dot. The kind of blur you'd get if someone sneezed on a camera lens. Within minutes, the internet erupted. Not in awe, but outrage. Amateur astronomers, armed with backyard telescopes and second-hand lenses, were posting sharper images of comets millions of miles farther away. Meanwhile, NASA, with its Mars Reconnaissance Orbiter and the most powerful space camera ever built, has gone completely silent. The official excuse? A government shutdown. But that story's wearing thin, especially when China's Tianwen-1 and the UAE's Hope Orbiter are also mysteriously quiet. And here's the part that should make you uneasy. By the time you finish this video, 3I Atlas will be less than a week away from slipping behind the sun, vanishing from every telescope on Earth, right as it reaches its most active, unpredictable phase. If Harvard physicist Avi Loeb is right, what comes next could rewrite everything we think we know about what's possible in our cosmic neighborhood. So before we dive deeper, hit that like button, subscribe if you haven't, and tell me in the comments, where are you watching from? What time is it there? And do you believe we're being told the whole truth about 3I Atlas? If you want to help this story reach more eyes, share it on X, Facebook, Reddit, or with your friends. Thank you for standing with us as we chase the truth across the stars. Chapter 1. The photo drop that broke the internet. October 7th and 8th, 2025 will be remembered as the moment the space community collectively lost its patience. For months, we'd been building toward this. Only the third confirmed interstellar object ever detected passing through our solar system was making its closest approach to Mars. 7 different spacecraft from 4 space agencies were positioned to capture unprecedented images. The hype was real. Scientists promised us clarity, answers, maybe even proof of what this thing actually is. And then the images dropped. The European Space Agency's ExoMars Trace Gas Orbiter, positioned just 30 million kilometers from 3I Atlas during its closest approach on October 3rd, released a series of images that can only be described as profoundly underwhelming. A fuzzy white dot moving slowly across a starfield. No detail, no structure, nothing that would help us understand whether we're looking at a natural comet or something far stranger. The backlash was immediate and savage. Astronomy vibes. A popular space commentary account on X posted a side-by-side comparison that went viral within hours. On one side, a crisp, detailed image of Comet Lemon captured by an amateur astrophotographer with a simple, mirrorless camera. On the other side, the ESA's image of 3I Atlas. The caption read, "If a simple mirrorless camera can catch Comet Lemon, why can't NASA capture 3I Atlas passing close to Mars?" The post currently has over 40,000 reposts and counting, but it was the follow-up that really struck a nerve. Billions in funding, and this is the best photo they've got. Looks more like a weather balloon in a foggy backyard. To understand why people are so angry, you need to understand what we were expecting versus what we got. The Cassis camera aboard the ExoMars Trace Gas Orbiter has an angular resolution of 11.36 microradians per pixel. At 30 million kilometers, that translates to 340 kilometers per pixel. For context, the estimated nucleus of 3I Atlas is between 5 and 46 kilometers across. That means the entire solid core of this object would occupy, at best, a fraction of a single pixel in these images. But here's where it gets interesting. The ESA knew this going in. They knew their cameras were designed to photograph the bright Martian surface from just a few hundred kilometers away, not faint objects tens of millions of kilometers distant. Nick Thomas, the principal investigator for the Cassis camera, admitted as much in the official statement. This was a very challenging observation for the instrument. The comet is around 10,000 to 100,000 times fainter than our usual target. So why release images they knew would be inadequate? Why build up expectations for months only to deliver something that provides zero new information? The official story is that they released what they had, that these represent the best possible images from the equipment available. But the timing feels deliberate, almost like a pressure release valve. Give people something, anything to look at, while the real data stays locked away. Because make no mistake, there are better images, much better images, and they're being held back. Chapter 2. The Missing Crown Jewel. While the European Space Agency, or ESA, released only a few blurry dots of light, NASA's Mars Reconnaissance Orbiter was capturing something entirely different. On board was the HiRISE camera, short for High Resolution Imaging Science Experiment, the most powerful camera ever sent to another planet. Its vision is so precise that, from orbit, it can distinguish objects on the Martian surface no larger than a kitchen table. When 3. I Atlas swept past Mars on October 3rd, HiRISE observed it from millions of kilometers away, achieving a resolution of roughly 30 kilometers per pixel. To put that in perspective, each single pixel in its image covered an area about the size of a major city, roughly the distance between Los Angeles and Pasadena. Anything smaller than that, mountains, craters, or the glowing dust streaming from its tail, would blend together into a single, shimmering point of light. Even so, that level of detail was more than 10 times sharper than what ESA's cameras had managed. If 3I Atlas possessed any structure, any strange geometry, any hint that it was more than just a natural comet, HiRISE would have seen it. Avi Loeb, the Harvard physicist who's been tracking 3I Atlas since its discovery, put it bluntly in his latest blog post. The brightest pixel in the HiRISE image will provide the best constraint yet on the area of 3I Atlas. We are all hoping that the HiRISE team will release their images as soon as possible. That was written on October 7th. It's now October 8th. Still nothing. The official explanation is the United States government shut down. Over 15,000 NASA employees, more than 80% of the agency's workforce, have been furloughed. The agency's website isn't being updated. Public communications have ceased. It's bureaucratic paralysis at the worst possible moment. But here's what doesn't add up. The ESA released their images. They're a European agency completely unaffected by American political dysfunction. China's Tianwen-1 orbiter was also positioned to observe 3Y Atlas, with its moderate resolution imaging camera, also silent. The UAE's Hope orbiter, equipped with the Emirates Exploration Imager, had a clear shot as well. Nothing. Multiple space agencies, multiple sovereign governments, with completely separate bureaucracies and priorities, all simultaneously unable or unwilling to release their best data on the most scientifically significant object to visit our solar system in years. The pattern is hard to ignore. Social media is ablaze with speculation. Some say coordination. Others say something was seen that requires careful review before public release. The more conspiracy-minded suggest the images show something so anomalous that releasing them without proper context would trigger mass panic. That last theory sounds absurd until you remember what's been happening over the past week with amateur observations. Because while the professional space agencies have been cagey with their data, backyard astronomers have been capturing images that raise more questions than they answer. Chapter 3. When amateurs see what professionals won't show. On October 3rd, the exact day 3 Atlas made its closest approach to Mars, a Portuguese amateur astronomer operating under the username Dobsonian in power uploaded an image that immediately went viral. Using nothing more than a solar telescope from his backyard and some aggressive digital enhancement, he captured what appears to be an angular structure within 3I Atlas. Dark geometric shapes, protrusions that don't match the typical diffuse glow of a comet's coma. The caption he added was simple but loaded with implication. What on earth is it? Within 6 hours, the image had been shared across every major astronomy forum, subreddit, and social media platform. The reaction split into two camps almost instantly. One group saw clear evidence of artificial structures, proof that 3I Atlas is not what mainstream science claims it to be. The other group dismissed it as classic pareidolia, the human tendency to see patterns where none exist, amplified by processing artifacts from inappropriate equipment. The debunkers had solid technical arguments. Solar telescopes use specialized filters designed for observing the sun's extreme brightness, not faint deep space objects traveling at interstellar velocities. The equipment simply wasn't built for this kind of observation. Add aggressive digital enhancement to compensate for the inadequate setup, and you're essentially asking an algorithm to invent details that aren't really there. It's the astronomical equivalent of enhancing a blurry photo until you start seeing faces in the noise. But here's where the story gets complicated. Dobsonian power isn't some random internet conspiracy theorist with a cheap telescope and too much imagination. He's a respected amateur astronomer who's been sharing legitimate astrophotography work for over a decade. His YouTube channel features careful documentation of his equipment, his methods, his image processing workflows. This isn't someone trying to manufacture evidence for clicks. And when pressed on the anomalous structures in his 3I Atlas image, he didn't double down with wild claims. Instead, he acknowledged uncertainty. He promised to try again when the object becomes visible from Earth in early November after passing behind the sun. His response was measured, scientific, appropriately cautious, which makes the reaction to his image even more telling. Within 24 hours, multiple websites published articles specifically debunking his capture. amateur telescope captures strange 3I Atlas image. Here's why it's not what it seems. The timing felt coordinated, the tone felt defensive, as if someone needed to quickly establish the narrative that nothing unusual had been photographed, that any apparent anomalies were merely technical artifacts, before the image could gain too much traction. And then the enhancement wars began. Users across Reddit, Twitter, and various conspiracy forums started downloading the original ESA images and running them through their own processing algorithms. Some use standard astronomical image stacking techniques. Others employed AI upscaling tools designed for enhancing low-resolution photos. A few went full chaos mode with machine learning models trained to reconstruct fine details from limited data. The results varied wildly. Some showed nothing but slightly sharper versions of the same fuzzy dot. Others revealed what appeared to be distinct geometric patterns, edges, structures that seemed too regular to be natural ice and rock. The problem is that once you start aggressively processing, and especially with AI tools, you're no longer looking at what's actually there. You're looking at what an algorithm thinks should be there based on its training data. If you train an AI on thousands of images of spacecraft and then ask it to enhance a blurry dot, it might very well invent spacecraft, like details, because that's what it's learned to recognize. It's a scientific dead end wrapped in the illusion of clarity. But the proliferation of these enhanced images had an unintended effect. They muddied the water so thoroughly that distinguishing between legitimate amateur observations and outright fabrications became nearly impossible. Within 48 hours of the ESA photo release, there were dozens of supposedly enhanced versions circulating online. Some showed metallic surfaces, others depicted what looked like solar panels or antenna arrays. A few even included running lights and visible thrusters. Most were obviously fake, digital art created by people with too much time and too much Photoshop skill. But mixed in with the noise were a handful of images that felt different, more subtle, less sensational. Images that showed just enough unusual regularity to make you wonder whether something real was being obscured by the flood of obvious hoaxes. Chapter 4. The 4chan leak that won't go away. On October 4th, an anonymous user on 4chan's paranormal board posted what they claimed was insider information about 3I Atlas. The post was titled simply ESA Data Leak, and it began with a credential claim that was specific enough to sound legitimate, but vague enough to maintain anonymity. I am a doctoral researcher working with the European Space Agency with continuous access to the combined observational data of 3I Atlas. Internet leaks are a dime a dozen. Most are easily dismissed as creative fiction or outright trolling, but this one was different. The level of technical detail was unsettling. The poster didn't make wild claims about alien invasions or secret military operations. Instead, they laid out a series of specific observational anomalies that, if true, would fundamentally challenge our understanding of what 3I Atlas actually is. First anomaly: chemical impossibility. According to the post, spectroscopic analysis shows 3I Atlas is releasing approximately 100 kilograms of nickel gas per second, but with almost no iron emission. In normal stellar and planetary chemistry, Nickel and iron are inseparable twins. They form together in supernova explosions. They travel together through interstellar space, and they appear together in comets and asteroids. Finding abundant nickel with virtually no iron is like finding smoke without fire. It violates basic assumptions about how matter behaves in natural cosmic environments. The second anomaly, thermal contradiction. The object is releasing massive amounts of gas and dust, the characteristic signature of an active comet being heated by the sun. But infrared observations show it remains cold, far colder than it should be given its outgassing rate and proximity to solar radiation. The poster compared it to watching someone sweat profusely in a freezer. The physics don't match the observation. The third anomaly, trajectory precision. The post referenced what Avi Loeb has been saying publicly, that 3I Atlas arrived with an orbital inclination of just 4.89 degrees relative to Earth's ecliptic plane. But the 4chan poster added something Loeb didn't emphasize. The trajectory isn't just unusual, it's a perfect straight shot from the direction of the galactic core. No wobble, no deviation, no signs of gravitational perturbation from nearby stars during its millions or billions of years traveling through interstellar space, as if it was aimed. Then came the part that elevated this from interesting speculation to something darker. The poster claimed the object fits the profile of what they called a post, biological entity, not a natural comet, not a conventional spacecraft, something in between. They described it as having a 3-phase particle engine with an estimated power output of 75 megawatts, continuously transmitting an active signal and, in their words, probing our solar system. The post concluded with a theoretical framework. The poster suggested 3I Atlas might be a macroscopic quantum object, specifically something called a cue ball. It's an exotic theoretical construct from particle physics, a type of non-topological soliton that could theoretically exist at scales far larger than subatomic particles. If stable, a cue ball could have properties that seem impossible under normal physics. It could be incredibly dense while appearing diffuse. It could absorb and redistribute energy instantaneously across its entire structure, explaining the thermal contradictions. It could even explain the nickel without iron problem if the cue ball's internal quantum state preferentially produces certain isotopes. Within 18 hours, the post had been screenshot and shared across Reddit, Twitter, and dedicated UFO research forums. The conspiracy subreddit thread discussing it accumulated over 2,000 comments before moderators locked it for violating rules against unverified claims. But locking the thread didn't stop the conversation. It just moved it to other platforms, fragmenting into dozens of parallel discussions, each pulling the original post in different directions. Some focused on the chemical anomalies, others zeroed in on the cue ball hypothesis. A few started connecting it to earlier claims about 3E Atlas, potentially being the source of the 1977 WOW signal. Chapter 5. The 50,000-kilometer question. On October 4th, NASA's Perseverance rover, sitting in Jezero crater on the Martian surface, captured something in the night sky above. The image from its right navigation camera showed an elongated streak of light, roughly 4 times longer then it was wide. At first glance, it looked like a typical long exposure capture of a moving object. Comets and asteroids often appear smeared in images when the camera tracks stars instead of the object itself. Standard stuff. Except the math didn't work out that way. When people started calculating the apparent size of the streak based on Perseverance's known camera specifications and the distance to 3I Atlas at the time, they arrived at a disturbing number: 50,000 kilometers long. That's not a comet nucleus. That's not even a comet with a tail. That's something else entirely. For comparison, Earth's diameter is less than 13,000 kilometers. If this streak represented the actual physical size of 3I Atlas, we were looking at an object nearly 4 times wider than our entire planet. Social media exploded with speculation. Was 3I Atlas actually a massive cylindrical craft? Had it been masking its true size and shape this whole time behind a diffuse cloud of gas and dust? The timing felt significant. This image emerged just one day after the Mars flyby, right when all the professional space agencies went mysteriously quiet. Some saw it as confirmation that something deeply anomalous had been photographed, something that couldn't be easily explained away. The speculation reached high enough that Representative Anna Paulina Luna, a member of Congress known for her interest in unexplained aerial phenomena, reached out directly to Avi Loeb for his analysis. Think about that for a moment. A sitting member of the United States House of Representatives felt compelled to contact a Harvard physicist about a photograph from Mars. That's not normal protocol. That suggests someone in official channels was concerned enough to want expert interpretation outside the usual NASA communication pipeline. Loeb's response was thorough and, on the surface, reassuring. He calculated that the Perseverance navcam has an angular resolution of 0.33 milliradians per pixel. At the distance of 3I Atlas when the image was taken, approximately 38 million kilometers, that translates to about 12,500 kilometers per pixel. The streak in the image spans roughly 4 pixels, which gives you that 50,000 kilometer length. But Loeb argued this was an artifact of composite imaging. The streak wasn't showing the actual size of 3I Atlas. It was showing the path the object traced across the Martian sky during a long integration time, likely around 10 minutes of stacked exposures. His reasoning was solid. Mars orbits the Sun at 24 kilometers per second. 3I Atlas was traveling at 67 kilometers per second relative to the Sun in the opposite direction, giving it a relative velocity of over 90 kilometers per second compared to Mars. Over 10 minutes, that's exactly 54,000 kilometers of travel, perfectly matching the observed streak length. The shape wasn't the object. It was the object's motion smeared across time. Case closed. Write the cylinder theory debunked by basic physics and careful math. Except Loeb included one sentence in his analysis that conspiracy theorists latched onto like a lifeline. He wrote, if the navcam images represent single snapshots with an exposure time below 328 seconds, then the brightness and angular length of the observed source imply that it is not 3I Atlas. In that case, the source might be much closer to the camera, capable of being smeared into an elongated image with a smaller spatial size and a smaller speed. Wait, if these are single-frame captures, then what Perseverance photographed wasn't 3I Atlas at all. It was something else. something closer to Mars. That qualifier opened a door that no amount of subsequent clarification could fully close. Because NASA hasn't confirmed whether the image is a composite or a single frame, they haven't released the metadata, they haven't provided the exposure time or the number of stacked images. The government shut down excuse supplies here too. No staff to process requests, no one available to confirm basic technical details about how the image was captured. Chapter 6, 48 Years of Silence. August 15th, 1977. Ohio State University's Big Ear radio telescope detected a 72-second burst of radio energy so unusual, so perfectly structured, that astronomer Jerry Amon circled it on the printout and wrote one word in red pen: wow. For nearly 5 decades, that signal has remained one of the greatest mysteries in the search for extraterrestrial intelligence. It came from the direction of Sagittarius, near the constellation's densest star fields. It was narrowband, focused at one specific frequency, and it has never repeated. Hundreds of follow-up observations, thousands of hours of listening time pointed at the same region of sky. Nothing. Just that one burst 48 years ago, and then eternal silence. Until Avi Loeb ran the numbers on 3i Atlas. He calculated where the object was on August 12, 1907, just 3 days before the WOW signal was detected. The answer: approximately 600 astronomical units from Earth, roughly 600 times the distance between Earth and the Sun. But more importantly, he calculated what direction 3i Atlas was coming from at that time. Right ascension, 19 hours, 40 minutes. Declination, negative 19 degrees. The WOW signal came from right ascension, 19 hours, 25 minutes. Declination, negative 27 degrees. The two directions are separated by approximately 9 degrees. In the vastness of space, with random objects coming from literally any possible direction, the probability of this alignment is about 0.6%. Not impossible, but deeply suspicious. Loeb didn't stop there. He asked the next logical question. If 3i Atlas sent the WOW signal from 600 astronomical units away, how powerful would the transmitter need to be? The math is straightforward. The detected intensity was between 54 and 212 Jansky across a 10 kHz bandwidth at 600 AU distance. That corresponds to a transmitter output between 0.5 gigawatt and 2 gigawatts. For reference, a typical nuclear reactor on Earth produces about 1 gigawatt. So we're talking about nuclear power plant levels of energy focused into a narrow radio beam. Not impossible for an advanced civilization. Actually quite reasonable if you're trying to send a detectable signal across interstellar distances without wasting energy on omnidirectional broadcasting. There's another detail that makes the connection harder to dismiss. The WOW signal was observed at a frequency of 1420, 4556 megahertz. Blue shifted by approximately 10 kilometers per second toward Earth relative to the hydrogen line. That blue shift indicates the source was moving toward us 3y. Atlas is currently the Sun at about 60 kilometers per second. Loeb suggests that if this object has maneuvering capability, it could have been moving slower in 1977, then accelerated after detecting habitable zone planets in our solar system. A reconnaissance pulse, a radar scan checking for signs of technological civilization before committing to a closer approach. Here's what makes this entire connection so frustrating. It would be trivially easy to check. Point a radio telescope at 3I Atlas. Listen at the hydrogen line frequency. If it's transmitting, we'll know within hours. If it's silent, the WOW signal connection is probably coincidental. Simple test. Definitive answer. And yet, as Loeb noted in his latest blog post, not a single radio telescope has reported data on 3I Atlas. The Very Large Array hasn't looked. The Arecibo telescope is destroyed. The Green Bank telescope hasn't published observations. Even SETI, the organization literally dedicated to finding extraterrestrial signals, hasn't publicly announced any monitoring efforts. The silence from the radio astronomy community is deafening. Chapter 7. The Path That Shouldn't Exist. Imagine throwing a dart at a globe from across a room while blindfolded. Now imagine that dart not only hits the globe, but lands within a few degrees of the equator. That's roughly the statistical improbability we're dealing with when we look at how 3I Atlas entered our solar system. Objects coming from interstellar space can arrive from literally any direction. They should be randomly distributed across the celestial sphere, coming in at all possible angles. And yet, 3Y Atlas arrived with an orbital inclination of just 489 degrees relative to Earth's ecliptic plane. Less than 5 degrees. That puts it in less than 1% of possible arrival angles. AVI Loeb has been hammering this point in every interview, every blog post, every public statement since July. The trajectory is anomalous, not just unusual, statistically profoundly unlikely for a random interstellar object. To understand why, you need to think about how objects move through the galaxy. Stars in the Milky Way disk orbit the galactic center with some average velocity, but they also have random motions up and down, side to side, like bees swarming around a hive. That randomness means objects ejected from other star systems should arrive at our solar system from all directions, with roughly equal probability. There's no preferred direction, no cosmic highway that funnels interstellar visitors into our ecliptic plane. And before someone suggests that maybe objects from the Milky Way disk naturally arrive at shallow angles, Loeb addressed that too. The galactic disk itself is tilted about 60 degrees relative to our solar system's ecliptic plane. 60 degrees, that's more than 10 times larger than the inclination of 3I Atlas. If this object came from a typical star system in the galactic disk and was ejected randomly, we'd expect it to arrive at a steep angle, not a shallow one. The alignment is backwards from what galactic geometry would predict. Compare 3. Atlas to the only other interstellar objects we've detected. Oumuamua, discovered in 2017, arrived with an inclination of 123 degrees, wildly tilted, coming in from above the solar system plane. 2I Borisov, spotted in 2019, had an inclination of 44 degrees, still steep, still consistent with random arrival from interstellar space. Both of those objects behaved exactly as expected for natural interstellar visitors. 3I Atlas is the outlier, the anomaly, the one that doesn't fit the pattern. Loeb calculated the probability of this alignment assuming random directions. Less than 1% chance. Some colleagues pushed back, suggesting maybe his statistics were too conservative. Maybe the true probability is closer to 5 or 10% when you account for various selection effects and observational biases. Fine. Even at 10%, you're still looking at something that should only happen once in every 10 interstellar objects we detect, and we've only detected 3. The odds of the third one being the rare exception rather than the rule are not in favor of coincidence. Now, layer that on top of everything else. The WOW signal alignment, also less than 1% probability. The chemical anomalies with nickel but no iron. The thermal contradictions. The missing high-resolution images from multiple space agencies. The government shutdown happening at the exact moment we need NASA most. Any single one of these things could be explained away. Coincidence. Measurement error. Bureaucratic incompetence. But when you start stacking anomalies, when you start multiplying small probabilities together, the compound in probability becomes harder to dismiss. There's a principle in statistics called the prosecutor's fallacy. It's the mistake of treating multiple independent low-probability events as if they're related when they're actually just random coincidences that happen to cluster together. If you flip a coin enough times, eventually you'll get 10 heads in a row. It doesn't mean the coin is rigged. It just means you flipped it enough times for unlikely sequences to occur. Skeptics will argue, that's what we're seeing with 3I, Atlas, a natural comet that happens to have several unusual but ultimately explainable properties that coincidentally appeared together in the same object. Unlikely, sure, but not impossible. The counter-argument is equally valid. If something walks like a duck, quacks like a duck, swims like a duck, and has duck DNA, at some point you have to consider the possibility it might actually be a duck. Or in this case, if an object arrives on a statistically unlikely trajectory, shows chemical signatures that don't match natural processes, correlates with a 48-year-old unexplained radio signal, and prompts multiple governments to withhold their best imaging data, maybe it's worth seriously considering that we're not looking at a random chunk of ice and rock from another star system. Chapter 8. When questions become dangerous. Something strange started happening around October 5th. Users across multiple platforms began reporting that their posts about 3I Atlas were disappearing, not being flagged or marked as misinformation, actually vanishing. A Reddit user documented posting a detailed thread analyzing the chemical anomalies from the alleged ESA leak. The thread gained traction, accumulated hundreds of upvotes, and dozens of comments within 2 hours. Then it was gone, not removed with a moderator explanation, just deleted from existence. When the user tried to repost, the submission wouldn't go through. Shadow banned without notification or explanation. On Twitter, now X, several accounts noticed similar patterns. Astronomy Vibes, the account that went viral criticizing the ESA photos, reported significant engagement drops after October 7th. Posts that would normally reach tens of thousands of people were suddenly plateauing at a few hundred views. No official restrictions, no warning messages, just algorithmic suppression quiet enough to be deniable, but aggressive enough to be effective. Other creators in the space astronomy community noticed the same thing. Videos about 3Y Atlas that would typically perform well were getting a fraction of their usual reach. YouTube presented a different problem. Content creators who posted analysis videos speculating about 3I Atlas began receiving demonetization notices. The stated reason varied. Some were flagged for discussing sensitive topics without proper context. Others were categorized as potentially misleading content about scientific matters. A few got hit with the vague but ominous label of content that may not be suitable for all advertisers. The pattern was clear. You could make a video saying 3i Atlas is definitely just a comet and mainstream science has it figured out. That was fine, monetized, promoted, but suggests there might be anomalies worth investigating. Suddenly your video becomes advertiser unfriendly. Facebook's approach was the most overt. The platform's fact-checking system, operated by third-party verification organizations, started aggressively labeling 3i Atlas content. Post, sharing the 4chan leak, got slapped with missing context warnings. Claims about the trajectory anomalies were flagged as partly false, even when the posts were just quoting Avi Loeb's published calculations verbatim. The fact-check articles offered reassurance. Space agencies confirm no threat from interstellar comet. Experts say unusual features likely natural processes. The subtext was clear. Don't worry. Don't speculate. Trust the authorities. Move along. The timing felt coordinated. All of this ramped up within 48 hours of the ESA photo release. Writers' public frustration was peaking over the lack of quality images. It's the kind of pattern that makes conspiracy theorists feel vindicated and makes skeptics roll their eyes at overreach paranoia. Because here's the thing, social media platforms suppress content all the time. Algorithms change. Engagement fluctuates. Fact-checkers flag misinformation. These are normal platform operations, not evidence of coordinated censorship. Unless there's a pattern, unless it's all happening at once. Targeting one specific topic, right at the moment when public interest is highest and official answers are most absent. Some creators started using coded language to avoid suppression. Instead of 3i Atlas, they'd say the visitor or the object. Instead of alien or extraterrestrial, they'd use non-terrestrial or anomalous. It was like watching people develop a new vocabulary to discuss something the platforms didn't want discussed openly. The Streisand effect in real time. The more the content got suppressed, the more people assumed there was something worth hiding. The more aggressively fact-checkers pushed back, the less people trusted the official narrative. Every attempt to manage the conversation just amplified the suspicion that the conversation needed to be managed. Chapter 9. The Moment We Can't Watch. October 29th and 30th. Mark those dates. In less than 72 hours from now, 3i Atlas will reach perihelion, its closest approach to the Sun. It will pass at a distance of approximately 202 million kilometers, just inside the orbit of Mars. For a natural comet, this is the moment of truth. The intense solar radiation at that distance should cause dramatic outgassing, possibly even fragmentation. We've seen it happen before. Comets get close to the Sun, the heat becomes too much, and they break apart into pieces. Spectacular when it happens. And if 3i Atlas is just an ordinary chunk of ice and rock from another star system, that's exactly what should occur. But here's the problem. We won't be able to see it. 3i Atlas will be on the opposite side of the Sun from Earth during its perihelion passage. Every ground-based telescope on our planet will be useless. The object will be lost in the solar glare, completely hidden from observation during what should be its most active and revealing moment. Some are calling it unfortunate timing, others see it as suspicious convenient. If you wanted to do something without being watched, you couldn't pick a better window. Avi Loeb has been explicit about what happens next. In his October 3rd blog post published on the day of the Mars flyby, he laid out two scenarios. If 3I Atlas is a natural comet, it may erupt in a flare of outgassing or break up into icy fragments soon. The sunlight will deposit gigawatts of power onto its surface. That energy has to go somewhere. For ice and rock, it goes into vaporization, sublimation, possibly structural failure. But then Loeb added the alternative. Alternatively, if it is technological, it may maneuver to benefit from the sun's gravitational assist, or release probes that could intercept the Earth or other planets owing to its retrograde orbit, opposite in direction to the motion of the planets around the sun. Read that again. Release probes that could intercept Earth. He's not talking about passive observation anymore. He's talking about active deployment. The retrograde orbit is key here. 3I Atlas is moving opposite to the direction planets orbit the sun. That means any probe it releases doesn't have to fight it against planetary motion to reach us. It can simply drop into an intercept trajectory and let orbital mechanics do the work. From behind the sun, hidden from our view, it would be trivial to launch something toward Earth that wouldn't be detected until it was already close. Loeb went further. He wrote, "When you look at the sun in the coming weeks, keep in mind that 3I Atlas is passing behind it. If 3I Atlas will maneuver towards Earth, when it reappears on the other side of the sun, the financial markets may crash. Financial markets may crash. That's not metaphor. That's not hyperbole. He's suggesting that if this object demonstrates technological capability, if it alters course toward Earth after perihelion, the economic and social consequences would be immediate and severe. Stock markets respond to uncertainty. The uncertainty of a potentially hostile interstellar object actively changing its trajectory toward our planet would be existential level uncertainty. The timing of everything compounds the tension. The government shutdown means NASA is offline during the critical observation window. The best images from the Mars flyby are still unreleased. Amateur astronomers can't observe the object for the next month because it's behind the sun. Radio telescopes haven't checked for transmissions. We're flying blind into the most important moment of this entire encounter, and whether through incompetence or design, we've created a situation where we won't know what 3I Atlas does at perihelion until it's already done it. There is one group watching. The Galileo project, led by Loeb himself, operates 3 observatories, one in Massachusetts, one in Pennsylvania, one in Nevada. They're equipped with high-resolution cameras, infrared sensors, and radio receivers designed specifically to detect anomalous aerial phenomena. During late October and early November, all 3 observatories will be in maximum operational mode, monitoring the skies for anything unusual. If 3I Atlas releases probes, if there's enhanced UAP activity correlated with its perihelion passage, the Galileo instruments might catch it. Might being the operative word, 3 observatories covering a small fraction of Earth's sky. If something comes and it avoids those specific observation zones, we'll miss it entirely.